Pressure. Pressure is the force that is exerted per unit area. It's how spread out the force is. If the force is all contained in a very small area, there's going to be a great pressure. But if this force is spread out over a large area, then the pressure is going to be significantly smaller. Okay? Pressure is a scalar. There's no direction associated with pressure. The symbol is the capital letter P, and the equation is pressure is the force divided by the area. The units that we use in our physics class are pascals. A pascal is a Newton per square meter. Remember, we use newtons for force, and we use meters when we measure a length, and an area is a length times another length, so a meter squared there. Okay, and we get a pascal, which can be abbreviated PA. Okay, however, in everyday life, you've probably heard some other units of pressure used before. For example, a millimeter of mercury. Okay, that is a common unit for pressure that's used in nursing. PSI, a pound per square inch. You've probably seen that when you go to inflate a ball or you go to inflate the tires of your car. Okay, it's used often in the United States as a unit for pressure. And then you've got this atmosphere. Okay, because the atmosphere is exerting pressure on us right now. And so we just call the pressure exerted by the atmosphere at sea level an atmosphere. Okay? So what things can affect pressure? Well, our equation is the force per unit area. So definitely the force can affect it, and the area can affect it. So the larger the area, you're going to divide by a bigger number here, so you're going to get a smaller pressure. Okay? Similarly, the larger the force, if I start with a bigger number here, divide by the same area, I'm going to get a bigger pressure. Okay, so if you increase your force, bigger pressure. If you increase your area, smaller pressure. So let's think about this, okay? As far as if we go to a bed of nails, okay? If you only have one nail, okay, like that, there's your nail, and you have to put all of your body weight on that one nail, okay, there's going to be a lot of pressure, okay? However, if you've got two nails, you've just cut the pressure in half, okay, because now it's divided up over twice the area. If you have three nails, you've cut the pressure into a third of what it used to be, okay? And that's why when we do the bed of nails demonstration, we want to use a bed that has a lot of nails in it, okay? The more nails, the more area, the less pressure. All right. But we also said about this atmosphere, because the atmosphere exerts a pressure on us. That's because the atmosphere is a fluid, and the deeper that you go in a fluid, the greater the pressure. Okay? So let's take this and think about if you're going swimming. You swim down into the deep end and you go down to the 12 feet. Sometimes you feel that pressure on your ears and you don't even like to be down there. That's because the deeper you go, the greater the pressure. That's also why when people scuba dive, there's a limit to how far you can go down. Okay? Because the pressure will be exerted on you, and once there's a lot of pressure exerted on you, there's nitrogen released within your body, and as you start to resurface, that nitrogen collects at your joints, and if you resurface quickly, all that nitrogen it's collecting could cause a blood vessel to burst and could cause some internal bleeding. Okay, so to be careful with those things. Another everyday example or real life example would be if you are going into a plane, okay? As you rise up, oftentimes people chew gum and you see people kind of yawning and they're trying to get their ears to pop, okay? Reason being, as you go up, okay, you're going higher in the fluid, so the pressure is becoming less. There's less pressure up there. And even though they pressurize the cabins, you can still feel a little bit of a difference, okay? And so you try to equalize the pressure on the inside, the outside of your body, and the one way to do that is to kind of chew gum, pop your ears, okay? So, this air pressure. The air pressure at sea level, we call that 1 atmosphere, and 1 atmosphere in pascals is 101,300 pascals, or 14.7 pounds per square inch. So if you are at sea level, you are experiencing 14.7 pounds of force for every square inch of your body. Okay, and that seems like a lot. So why aren't you crushed? Well, your body is exerting a force from the inside out as well, and that pressure is equalized. Suction, okay? Suction is caused by an imbalance of pressure. If you've got less pressure on the inside of a suction cup, okay, and more pressure on the outside, we say that it's suctioned, okay? And that's caused by the imbalance in pressure because the high pressure area wants to move into the low pressure area. And then we've got Pascal's principle, and this principle states that increasing the pressure at any given point will cause the pressure increase the pressure equally throughout the fluid. So if you have a 2-liter bottle of soda and maybe you got the top even screwed on it, okay? If you start squeezing that, you're going to increase the pressure, not just where you're squeezing, but throughout the entire fluid. Another example that I forgot to mention about the deeper you go in a fluid, the greater the pressure. When you get your blood pressure taken, they take it in your upper arm, okay? And the reason they do that is because the deeper you go in a fluid, and we are immersed in the fluid of air, okay? We've got the atmospheric pressure on us. So the deeper we go in that fluid, the more pressure there is. So that means the pressure down here in your ankle is going to be greater than the pressure up here in your arm. And why do we want the pressure in your arm? Because we really want the blood pressure in your heart. And so in your upper arm, that's about the same height as where your heart is going to be. Now they are making these new blood pressure cuffs that go around your wrist. And you'll notice that if you use one of those, they ask you to fold your arm up and put it over top of your chest. Again, so it's at the same height as your heart.